Variance. Example. Variance shows the degree of variability from the mean. Variance can be calculated in another form. The mean of x squared is based on the sum of the squares of x sub I. Wonder which equation to use in what conditions. Difficult for me to imagine too. Let's give some example data sets. Example 1. Let's have 5 samples. The mean is 6, which is an integer. The difference from the mean, which can have both positive and negative values. The sum is 0. Because negative values offset positive ones. The square of the difference from the mean is always a positive value. The sum of these squares is, of course, positive as well. To calculate the variance, if the mean of x sub I is an integer, use this standard sigma notation. Example 2. In this second example, let's have 5 samples, just like in the first example. The mean is 6.2, which is not an integer, but a decimal, in this example. The difference from the mean is also a decimal, which is much more complicated than an integer. The sum of the differences is 0. That's enough. I can't take it anymore. Too hard to calculate for me. Instead, calculate the square of x sub I, which is at least better than the square of the difference from the mean. I don't use this sigma notation, because the differences from the mean are decimals. Use this second notation with the mean of the square of x sub I. Wanna avoid the calculating the square with a decimal. Use fractions instead of decimals. Reduce fractions to a common denominator of 25. From a fraction back to a decimal. This time, looked at 2 formulas for variance with actual examples, how to choose and how to calculate. Use the sigma. If the mean is an integer, use the mean of the square of x sub I. If the mean is a decimal. Did I get smarter? Maybe. Haha. Bye bye then.